Okay, everyone, thank you for joining us in this next session where we're going to be talking about experiences. And we have you're really in for a treat because we have two great speakers in this session. The first group of people are from Digital Promise. And if those of you who are not familiar with Digital Promise, it was created with a mission to accelerate innovation in education to improve opportunities to learn for our students and for educators. And with us is Marika Conrad and Kelly Mills from Digital Promise. So I'm going to let them get started. Thanks for joining us.
All right, thanks everybody. And so I'm going to start sharing my slides, but before we start, or as we start, Marika and I are going to introduce ourselves. Hey, Christina's here too. And so I'm Kelly Mills. I am the project director of computational thinking at Digital Promise. I think why I'm joining this group is because I live in Maryland. I've lived in Maryland my whole life. I went to University of Maryland for 13 years, first as an undergrad, then master student in the MCCE program. And then I went into teaching and then got my doctorate from University of Maryland. So go Terps. And I joined towards the end of my graduate school. I really got involved in the computational thinking work. I taught the science methods course that integrated computational thinking as one of its central tenets, and did some professional learning there. And then when I finished my doctorate or postdoc, I joined Digital Promise to continue the professional learning work. So that's what I do at Digital Promise. And I'll let Marika and Christina introduce themselves next.
Hi everyone, my name is Marika Conrad. I am a learning experience designer at Digital Promise, and I'm still a Terp. I'm currently a PhD candidate at the University of Maryland. Had the pleasure of working with Kelly while she was postdoc there, and then continued to work on the project that if you went to Jan's session, you heard a little bit about. And so have been working on teacher professional development and curriculum around CT and computer science for the last 4 years. And I'm very excited to be here now sharing the work that I'm now doing at Digital Promise.
Hi everyone, I am Christina Luna. I'm the Senior Director of the Lifelong Learning Pathways team at Digital Promise, and we support educator professional learning that is competency-based through microcredentials. So I'm here to share about those projects and programs, and unfortunately I won't be able to stay very long, so I'll be here for a little bit, and please send any questions you might have to me. I shared my email in the chat.
All right, great. So I'm just going to start talking, and feel free to drop any questions in the chat as we go along, and Marika is going to interrupt me anytime a question pops up or I miss something. Okay, so what we're going to talk about in really fast and probably 10 or 15 minutes is just how we're thinking about computational thinking at Digital Promise, how we promote computational thinking and our strategy, and then our professional learning and micro-credentials, which is probably why most people are here. So I'll go through the first part pretty quickly. First of all, Digital Promise is a nonprofit organization that brings together educators, researchers, and developers. And we have about a little over 100 people on our team that are working together. And oh, am I admitting people? I don't know. Okay, sorry.
No, I think Joelle will do it.
Oh, okay. I might have done it. Sorry, Joelle. Okay, so we believe in the power of network story research and engagement, and we work together with huge networks of educators across the United States. We currently are engaged with computational thinking work in the fall, and the districts which are represented as stars on the map. And we have about 8 computational thinking projects currently that are engaged with some or I guess one or a subset of each of these districts across the United States right now. You'll notice that Maryland actually isn't a star currently because we are engaged with MCCE, but not a district in Maryland. And you'll see that part of our strategy is actually engaging directly with districts to get the work on the ground. So this, Marika is going to talk a little bit about how we're defining computational thinking. Go ahead.
Yeah, so we think about how computational thinking is a source of powerful learning for students and how it can be used to really enhance students' learning experiences. And so we believe that to prepare students for this increasingly computational world, that they need opportunities to go beyond using a computer just to gather information or present, and they need opportunities to really build computational thinking skills and use those skills within practices. Kelly, will you go to the next slide for me? So these computational thinking skills are kind of the foundation of how we see computational thinking. They're the cognitive processes that are necessary to engage computational thinking and problem solving. So we represent them in kind of everyday language here, in an attempt to try and make computational thinking a little more engaging and what's the word? Within reach for teachers, because I think sometimes our vocabulary can be a stumbling block, but this includes things like abstraction, automation, decomposition, and debugging, which you see all represented here. Next slide, please, Kelly. So we think of these computational skills as then the building blocks for the computational practices that students are engaging with. And we kind of have put those practices into three groups: collecting, analyzing, and communicating data, automating processes and procedures, and using models to understand systems. And I'm going to go quickly into each one of those. Next slide. So collecting, analyzing, and communicating data centers around using data science to interrogate data that's collected by students or that's available to them for exploration. And this includes not only gathering and analyzing data, but also presenting that data to others in a clear and concise manner. And data practices can really be integrated across the curriculum and provide opportunities for students to use data within their communities in ways that are culturally relevant, in ways that are critical to start to understand the world in which they live. Next slide. Automating processes and procedures includes algorithms, coding, and programming. So a lot of the stuff that we think of as CS in the school kind of fits in here. These skills are used by students as they're breaking down and understanding concepts across the curriculum. And we think about how programming can be used as a means of sharing and enhancing learning by creating animations or stories or short projects. And so that you're taking that disciplinary information and showing it through a program. And lastly, using models to allow students to better understand systems. And so these systems are commonly discussed in science, but really exist across the curriculum. And using models and computational simulations is a way for students to engage in phenomena, specifically those that are spatially or temporally too large or too far away for our students to engage with, or are too small to be seen. And so using these models, students can gather data, they can manipulate variables, and they can really explore the world in a safe and meaningful way.
All right, so now I'm going to take the next few minutes to talk about our 4 main commitments to computational thinking and how we're working with districts and educators to move our work forward. And so our first commitment is a commitment from district leadership. So we work with leadership at the district level to really develop pathways for computational thinking integration that are consistent, cumulative, and competency-based. And we have currently NSF-funded project CT pathways that we're working with a number of districts across the United States to develop these K through 12 pathways. And we're actually piloting a toolkit that you can explore. I think I'll just share all these links later so I don't have to keep dropping them in the chat. That actually has resources for district leaders to get together with educators and curriculum specialists to develop these consistent, cumulative, and competency-based opportunities. I'll skip over that slide for the sake of time. Our second commitment is the inclusion of participation of students historically marginalized from computing. Oh, those bullets are wrong, Kelly. So those bullets should say asset-based and beyond access. So really drawing on the assets of students and that are historically minoritized in computing, and also not just providing opportunities to students, but really designing opportunities with students that have been historically minoritized. And we have a number of resources that really dig into how we do that. We use design thinking to empathize or engage in empathy interviews with students, community members, and district leaders to understand how to design opportunities for students that are historically marginalized from computing. Third is participatory and iterative design. So this kind of builds on the last one. I didn't update any of these bullets. I am so sorry. So participatory and iterative design to really engage in co-design with the people that we are designing with and for. And an example of this is the STEMtastic Adventures app. And so this is actually a pre-K app for learners age 3 through 5, which takes them through this really cool game where they essentially building an algorithm through like a maze type of thing. And lastly, pre-K through 8 integration. We engage with educators for professional learning and design educator resources for teachers. So I think this is where this group is probably most interested in the computational thinking microcredentials. And then we also have developed a number of other resources in the computational thinking for next generation science toolkit. So let's just start talking about that. So our professional learning that we offer is both for elementary and secondary teachers. At the elementary level, we offer professional learning on the interdisciplinary. So instead of saying like CT broadly and then having the teachers figure out like where it makes the most sense for integration, we really work with teachers to understand where the most synergistic integration points are. And then with it's an interdisciplinary focus, whether that interdisciplinary focus is science and math or social studies and science or ELA, social studies and science, to really leverage computational thinking for enhanced learning experiences for students in ways that really, increase student engagement and disciplinary learning. And then at the secondary level in middle school, we, just because of the way that the schools are structured, the professional learning is offered for each specific discipline. And the reason for that is just so teachers can see this, really see the synergies between computational thinking and the disciplines that they're engaging in. Marika, do you want to add anything about the professional learning that I missed?
Nope, you're doing great.
Okay. I'm going to move right along to microcredentials. So I'm going to talk a little, it sounds like some people are already familiar with the concept of microcredentials, but I'll just give a little bit of overview for those that aren't. So a microcredential is a digital certificate that verifies an individual's competence in a specific set of skills. And to earn the microcredentials that we've designed, students submit evidence of, our teachers submit evidence of student work as part of them earning that microcredential. And microcredentials are especially powerful for computational thinking because there's less professional learning opportunities for them in credentialing pathways. So microcredentials are this really cool tool that teachers can use to learn this new and very important topic. And so microcredentials provide opportunities for teachers to align their classroom practice to research, find resources to, I won't read these, you could just read them, apply the job embedded practice, and be recognized and incentivized. So they're powerful for teachers to really take ownership of their own practice. And then they're powerful for district leaders because they can align to priorities, understand the impact of their professional learning because it connects professional learning to their practice. They're on-demand and self-paced, and they can be recognized and incentivized by teachers. And so to earn the microcredentials that we've designed, teachers plan a lesson, they select a microcredential, collect student work samples, upload those student work samples, and then also complete, I think, about 3 reflections, and then submit that to an evaluator, to 2 different evaluators to earn it. And so these are the micro credentials that we've designed for computational thinking. They're attached to computational thinking practices. And I'm just going to take you right on to the platform so you can I can kind of walk you through it. So this is the Digital Promise platform. You can search for micro credentials. These are the different issuing organizations, and then these are all of the different topics that we have micro credentials for. You can see that computational thinking is one of many. And so these are the 5 that we have for computational thinking for teachers right now. I'm going to take you into analyzing and communicating data. Okay, that's denied. Okay, so there's a resubmission. That's by design, but you wouldn't see this, because you haven't earned it yet. But so here's there's prompts, 2 prompts, and then teachers submit student work samples. There's rubrics to define it, and then finally a reflection prompt, and then they say whether it's awarded or not. So I'm going to go back to the presentation here. So we have micro credentials actually both for these 5 for teachers, and then we designed another 10 for students. So for the teachers, they need to collect the student evidence as evidence of them actually earning, like facilitating and teaching the computational thinking practice. The micro credentials for students are them demonstrating the computational thinking skill. So for instance, analyzing data, the student or the pre-service teacher would like analyze some data, submit the data that they analyzed as evidence to earn the micro credential. Whereas the teacher micro credential, they would need to plan a lesson and then submit a student's analysis of the data. So it's a little bit different. We conceptualize the student and the teacher micro credentials together as very powerful, because potential, especially for the university context, because pre-service teachers at lower that aren't yet in their internship could potentially engage in computational thinking learning as students, and then apply that learning as teachers to earn the computational thinking micro credentials for teachers. Another exciting application of micro credentials for teachers that we haven't yet explored but would love to so if we could kind of use micro credentials as kind of like a common assessment for educators from pre-service to induction years, so that they have some kind of common thread and they're not like, engaging in completely different systems of assessment in pre-service and induction, which they currently do, and it stresses them out a lot. So, all right, I don't know how fast I went, but hopefully I didn't go over. Okay, I don't think I
Did not. You left 6 minutes for questions, so
okay.
That's perfect.
Great.
Yeah, so if you have any questions, you can either put them in the chat or unmute yourself and ask. And yeah, we have approximately 6 minutes.
So Kelly, I'm going through a lot of the links in that you went through, and can you describe like your computational thinking pathways toolkit?
I sure can. So the computational thinking pathways toolkit is resources for district leaders to develop coherent, consistent, cumulative, so like opportunities for students to engage in computational thinking that are consistent across classrooms, cumulative, and build on each other from grade to grade, and competency based, so aligned to a CT practice such as algorithms. It's not drawing it like the thing that doesn't tie the pathway together is like a tool like Scratch. It is a competency such as algorithms. And then students are engaging in a competency algorithms from grade to grade in a way that builds on each other and is developmentally appropriate. So they might be using a specific tool or just engaging in like flowcharts at a younger age, and then they build on what they did in a way that makes sense throughout the grade bands. And the work that we do with districts is to really integrate it into existing systems to be coherent, like with the vision and the priorities that the district has currently in place, and also doesn't add it as an extra thing. So really working with a team of district leaders and educators so that this new thing isn't a whole other thing. It is a thing that is making all of the things they're already doing a little bit better. That's really the idea, or the hope.
And so your vision is that the teachers in the district that you're working with, or that team of teachers that you're closely working with, would have gone through and done the micro-credentialing and encourage the students in those classes to do the same? Is that kind of the vision?
That's a great question. So there's a lot going on here. And so I kind of want to tease it apart a little bit. So
Okay.
how districts develop their pathways and the tools that they use for professional learning is totally up to the district. So a district could use micro-credentials or they couldn't, depending on whether they, the synergies with the existing systems of professional learning. Some states value micro-credentials, like already have existing systems for valuing them. And they're like, yes, definitely, that's what the thing we use for professional learning. Other districts are really just trying to identify what those opportunities are. And they're a little bit before the professional learning. And so the pathway isn't distinct from the micro-credentials, but it's really up to the district whether or not they see value in micro-credentials for their pathway. The micro-credentials we've really primarily, and Christina, if she's still here, maybe she hopped off. I think she hopped off. The micro-credentials are primarily used for educators right now. We actually haven't yet piloted them with students. We just recently designed them, so we haven't yet piloted them. We have some ideas of how we might use them, but really we've done a great deal of micro-credentialing with educators and not with students yet.
Okay, thank you.
Yeah, I think that answers your question. Yep.
There's a question in the chat about how districts can become informed and involved with the CT. I'm assuming with the toolkit work, with the pathways work.
So they can, for now, we're piloting the toolkit with a number of districts. It's unclear to me. We do have a scale up grant. I think you could just email. So you can email me or Marika. And if you have follow-up questions about micro-credentials, Adelia is really the person that you want to direct those questions to. But if you have questions about the pathway work and district engagements, I think just send a follow-up email to me and I can talk to the team about how we might work out how if there's opportunities to engage in the current grant that we have, or what future opportunities might be. The current NSF grant that we have is coming to close this summer. So we have to kind of strategize. And if there's interest, we can definitely leverage that to, seek out a future opportunity.
There's also a question about whether we can talk more about the participatory design.
Yes, we would love to talk more about the participatory design. So I know that we're at time, or we'll be at time in 1 minute. So
yeah, you have 1 minute.
I don't want to steal anybody else's time.
Still have a minute.
So feel free to follow up with emails. We're happy to set up follow-up calls or anything with anybody who's interested to talk about anything we shared in this chat. And I'm really excited to hear about the micro-credentialing that Loyola's got set up and how it might be similar or different to the things that we're doing. So go ahead.
All right. Thank you so much.